Welcome to an introduction to equity in preparing tomorrow's manufacturing workforce, the first course in the suite of tools and resources for the Make the Future Connecting Girls to Manufacturing project. My name is Kathleen Fitzpatrick, and I am the Senior Program Manager for the National Alliance for Partnerships in Equity, or NAPE. I'm particularly interested in this effort to increase the number of females and females of color into manufacturing. I was educated as an industrial engineer and spent the first part of my career working in manufacturing as a process engineer, then as an engineering manager for Hewlett-Packard. While in charge of hiring, I was constantly frustrated at the low number of female candidates for our manufacturing positions. With the recent growth in advanced manufacturing, this is an area that has so much potential for females and students of color to contribute at a high level. I'm excited to be able to help you make a difference. The National Alliance for Partnerships in Equity Education Foundation has been tasked with engaging educators and recruiters in a network where they can learn and share best practices to increasing participation in advanced manufacturing pathways. This project is called Make the Future, Connecting Girls to Manufacturing, and it is aimed at increasing the participation of females in advanced manufacturing technologies. The tools and strategies that have been developed can be used with students and parents at the K-12 and community college level to increase the participation and retention of females and students of color in STEM and career and tech education, or CTE, leading to careers in advanced manufacturing. Advanced manufacturing faces a serious skills gap that could be solved by the inclusion of women and people of color, but a demographic shift in the manufacturing workforce will require a significant outreach effort with students and parents. We are excited that your organization has partnered with us on this important project and look forward to the work ahead. The purpose of this course is to introduce you to NAPE's work and to situate your perspective on all the modules offered as part of this effort to increase participation in advanced manufacturing pathways. As part of this hour-long webinar, I will be giving you an introduction to NAPE, who we are and what we do. I will be including all the information about the support from the Toyota Foundation and their goal to increase participation of females in the Advanced Manufacturing Technician, or AMT program. I will be sharing an introduction to NAPE's research-based equity and education framework, particularly NAPE's Culture Wheel. We will be exploring how NAPE's equity work can be applied to increasing participation of females in advanced manufacturing. Throughout, I will be referencing the other NAPE online resources available to you for further exploration. NAPE's online modules were designed to cover many different career paths, but this introduction will help you to think about what you learn there through the lens of manufacturing. First, let me introduce you to NAPE. The National Alliance for Partnership and Equity's mission is to build educators' capacity to implement effective solutions for increasing student access, educational equity, and workforce diversity. NAPE is made up of two separate organizations. NAPE, a member organization, is a consortium of state and local agencies, corporations, and national organizations committed to the advancement of equity and diversity in classrooms and workplaces. NAPE's efforts are focused on gathering and disseminating information, developing equity resource materials, sponsoring staff and professional development, partnering with other organizations, and influencing public policy. NAPE Education Foundation was established in 2002. We offer research-based, strategy-driven, practical application-focused professional development services that equip educators with tools to address specific school needs related to equitable learning environments, student academic success, and ultimately college and career readiness. The foundation shares NAPE's commitment to the advancement of equity and diversity in classrooms and workplaces. NAPE has 4 lines of businesses listed here. Professional development, we provide tools and curricula for educators through conferences, presentations, webinars, and formal training. Research and evaluation. We identify and report on research-based promising practices, as well as provide input to others' research. Technical support. We develop tools and resources for educational agencies such as schools, school districts, community colleges, and higher educational institutions. We also provide consulting services and expertise on access, equity, and diversity issues. Public policy and advocacy. We educate legislators and federal agencies on equity and diversity issues through policy briefs. We alert membership to policy issues. In particular, NAEP has been instrumental in communicating to its membership the equity changes included in the Perkins 5 reauthorization bill. Let's take a look at some statistics of why we are here talking about the issue of manufacturing, and in particular of women in manufacturing. I'd like you to consider the following facts. The United States has 12.5 million manufacturing jobs. That employs what percent of the workforce? 8.5%. U.S. manufacturing produces 18.2% of the world's goods. Where is it ranked in the world? Well, surprise, the U.S. manufacturing produces the largest percentage of the world's goods. It is number one. That's more than the entire economic output of China, who produces 17.6% of the world's products. Manufacturing jobs pay what on average? $26.50 per hour, which is a salary that is 12% higher than all other jobs. At that salary range, when you include benefits, is over $82,000 per year. Over the next decade, the U.S. will need nearly 3.5 million manufacturing jobs, but 2 million of those might go unfilled due to the lack of people with the skills to do the jobs. We are missing a great opportunity to fill that skills gap if we fail to recruit and retain women and underrepresented populations to educational pathways that will prepare them for careers in advanced manufacturing. Our equity gap will impact the industry's ability to keep manufacturing strong in America. In fact, women make up one of U.S. manufacturing's largest pools of untapped talent. 47% of the U.S. workforce is women. But what percent of women work in manufacturing? 29%. It is interesting to note that this is the same participation of women in STEM occupations, also 29%. What percent of industrial engineers and of mechanical engineers are women? 17.1% and 7.9%. This is a particular challenge since mechanical engineering is the largest field of engineering. Nearly 1/4 of engineering degrees that are conferred are mechanical engineering degrees. But as an engineering field, it has one of the lowest participation of women. One point to note is that most industrial engineers and mechanical engineers will funnel to jobs in manufacturing. Overall, 21.3% of engineering school graduates are women. Yet, women make up only what percent of practicing engineers? Only 11% of practicing engineers, down from 12% in 2011 and 13% in 2001. This says that work needs to be done on retaining females in the STEM workforce once they get there. These fields are areas of high growth, with engineering showing 11% growth and advanced manufacturing jobs showing a 12% growth compared to an average job growth of 5 to 9%. As we mentioned before, advanced manufacturing faces a serious skills gap that could be solved by the inclusion of women and people of color. But a demographic shift in the manufacturing workforce will require a significant outreach effort with students and their parents. Women are seen as an untapped resource in filling this need, but perceptions that women have of manufacturing careers needs to change, as well as society's perceptions of women in manufacturing needs to change as well. Funded by the Toyota Foundation and partnering with Project Lead the Way, the National Alliance for Partnerships and Equity Education Foundation has been tasked with engaging educators and recruiters in a network where they can learn and share best practices to increase participation in manufacturing pathways. This project will increase the capacity of educators at high schools and community colleges to implement research-based effective outreach strategies with the ultimate goal of increasing the percent of females and females of color in advanced manufacturing technician programs. What is advanced manufacturing? Advanced manufacturing describes manufacturing that is enabled by digital technologies, advanced systems, and processes requiring a highly trained and knowledgeable workforce. Advanced manufacturing job titles might include CNC or computer numerical controlled machine technician, welding engineer, additive manufacturing technologist, 3D printing engineer, robotics engineer or technician. Many students across the country are exposed to robotics during class or after-school activities. It's important to tell students that a majority of the robots used in the United States today are in manufacturing applications. So what they are learning can lead to an exciting career path that they may not have thought of. What is the Advanced Manufacturing Technician program? The AMT program blends classroom and lab instruction with on-site industrial experience. The AMT program includes a 2-year degree in advanced manufacturing automation technology, which combines cutting-edge curriculum, paid working experience, along with highly sought-after business principles and best practices of a world-class manufacturer. What makes the AMT program different? Students earn a wage while attending college and gain priceless work experience with a global manufacturing leader. Over 2 years, students can earn as much as $40,000 per year in salary, which, with planning, can cover all of a student's education expenses. There are also potential grants and financial aid available. Students will work as a paid intern approximately 16 hours a week at the AMT partner manufacturing facility, with many interns starting at $17 per hour. Those graduates hired by an AMT partner have the potential to earn as much as $64,000 a year, plus excellent benefits. Graduates with this level of training and experience are highly sought after by Toyota and other manufacturers within the 7 partner states and throughout the United States. Graduates may choose to continue their education to earn a bachelor degree in fields such as engineering, technology, or business. Many AMT partners offer full-time employees tuition assistance, which allows the completion of the BS degree with little or no cost. As part of this project, we have several strategies for achieving the goals. Throughout our suite of tools, you will access through NAEP's learning management system. You will be connected to valuable collateral and tools and strategies that you can use to conduct outreach and recruitment efforts with diverse females. By sharing best practices, we will increase your awareness of opportunities and careers in advanced manufacturing. We expect that the use of our suite of tools will lead to increased participation of females and female students of color in high school STEM courses, including Project Lead the Way's pre-engineering curriculum where PLTW exists. We also expect it to lead to increased participation of diverse females in advanced manufacturing supportive community college programs, such as the AMT Career Pathway Program. Overarching all of these strategies, our suite of tools will help teachers and counselors address stereotypes and perceptions about advanced manufacturing and the AMT program, including who is good or an ideal candidate for these career paths, the nature of the AMT program, and the benefits of advanced manufacturing careers. It will also provide best practices for recruiting and engaging females. At the end of our work together, you will have a customized recruitment toolbox with a focus on equity. As part of this project, NAEP has developed a suite of tools that you can access on the Learning Management System online. The suite has 8 modules. This video training is the first module, Introduction to Equity in Preparing Tomorrow's Advanced Manufacturing Workforce. The next 3 modules are on NAEP's online learning management system and are identified as Advanced Manufacturing Pathways online courses. They are Non-Traditional Student Success, STEM for Every Student, and Micromessaging to Reach and Teach Every Student. We suggest that you start with a micromessaging workshop after this one, as that provides a foundational framework for the other 2. The 5th module is a networking space intended to be a virtual discussion location where our participants can share information, resources, and materials. The 6th module contains our 9 best practices in equitable recruiting strategies for increasing participation in manufacturing programs. Each month, we will add items that you can download for use with your students. I will touch base on the 9 best practices at the end of this webinar. You will also have access to Make Your Futures YouTube channel, where we will curate videos that you can use with your students and their families. In addition to the tools, our participants will have the opportunity to work face-to-face at the annual Federation of Advanced Manufacturing Educators, or FAME conference, and at the National Alliance for Partnerships and Equity's National Summit for Educational Equity. Let's dig into the research around retention of females in non-traditional careers. Advanced manufacturing is no longer dark, dangerous, or dirty, but the stereotype persists. Today's manufacturing is more about brains than brawn. In order to attract females, we need to overcome stereotypes about manufacturing and revise our messaging to align to a different set of values. Micromessaging to Reach and Teach Every Student introduces cultural stereotypes about how implicit biases create barriers for students to pursue non-traditional careers like females in manufacturing. At this point, I would like for you to reflect and consider on our prompts and stop the recording and take a moment to complete these answers. So reflect and write in response to the prompts, creating a list, a description, and/or draw a picture or image. What do you think about careers for your students in manufacturing? What do the majority of your students think about manufacturing careers? What do they think about manufacturing professionals? For the first question, did you come up with words like challenging, exciting, rewarding, collaborative, high tech? Or did you come up with words like tedious, dirty, blue collar, low pay? When considering what your students think about manufacturing careers, what impact does your knowledge or the school counselor's knowledge about manufacturing have on your students' perceptions of manufacturing as a career? And with respect to manufacturing professionals, does it matter if your students know someone who's worked in manufacturing? Is their perception changed if they've experienced a manufacturing facility firsthand? What are the implications of these perceptions or stereotypes of manufacturing career paths? This is NAEP's culture wheel. NAEP's culture wheel creates a framework to examine equity in the classroom. The culture wheel says that stereotypes, or beliefs that we hold within our culture, shapes our biases, of which we are often unaware. These are also called unconscious bias or implicit biases about people and careers. We communicate our biases to those in our world through micromessages. The accumulation of micromessages over time impacts a person's belief in his or her ability to be successful in a course, class, college, and career. Let's explore these a little bit more in detail. Bias. Bias can be explicit or implicit. Explicit biases in education are mostly illegal today, thanks in part to Title IX, but also because of our changing culture. Implicit bias remain, as we as educators may inadvertently hold stereotypical beliefs that feed the micromessages we may be sending. Everyone has implicit biases. The most important thing we can do is to recognize it and work to counter them. Micromessages allow us to transmit both positive or micro affirmations and negative micro inequities, these biases, often without awareness. Our triggers are ingrained. Often the familiar is associated with known, safe, and is given greater value. And that which is unfamiliar is seen as alien and is given lesser value. Accumulation of advantage or disadvantage. While a small message may have a powerful impact, it can also have an impact without us knowing. It has been the accumulation of many messages over time that accumulate to serve as a foundation of a student's self-efficacy. Self-efficacy is one's perceived ability to produce an outcome, reach a level of performance, or achieve a goal. Self-confidence and self-esteem are part of self-efficacy, but self-efficacy goes further than either of these terms. One's self-efficacy, which develops early in life and over time, will impact career choices, including girls' belief in their ability to select STEM or CTE or careers in manufacturing. Lastly, behavior that is gendered, in other words, that fills into the stereotype for that gender, leads to a stereotyped perception that reinforces a cultural belief. Behavior that is not the status quo against gender stereotypes can have the effect of disrupting existing cultural stereotypes. The most important part is the point of change for educators is the point where we control our messages. But first, we must become aware of them. Just to reiterate, micromessages are communicated. They are small, subtle, unconscious messages sent and received when we interact with others. These micromessages can be microaffirmations. They can cause a student to feel valued, included, encouraged. They can be intentional, and they're positive. Or micromessages can be micro-inequities. They can make a student feel devalued, excluded, and discouraged. They are negative, and they are unintentional. To sum it up, culture shapes our biases and beliefs about people. We communicate our biases in our world through micromessages. The accumulation of micromessages over time impacts a person's belief in their own ability to be successful in a course, class, college, or career. The Advanced Manufacturing Pathways online course, called Micromessaging to Reach and Teach Every Student, explores this work in more depth. It looks at the impact that cultural stereotypes and implicit bias has on students' self-efficacy and therefore their participation in manufacturing pathways. This next workshop looks at the different ways that micromessages are communicated. There are activities containing examples of micro-inequities and the messages that they send to students. Most importantly, there are strategies to offset these micro-inequities, allowing educators to be more intentional about encouraging students to consider non-traditional careers. When reviewing micromessaging to reach every student, keep in mind that this work was designed to cover many different career paths, but it's important to think about what you learn through the lens of manufacturing. Let's explore cultural stereotypes and messages that are sent about non-traditional careers. Take a look at these two magazines. What are the cultural stereotypes that are depicted here? From an early age, girls get the message about what it is to be female, that above all else, appearance counts. Wake up pretty, hair, fashion, friends, without drama. In contrast, what is the message for the boys? They are encouraged to explore their future. The subheading says, astronaut, artist, firefighter, chef. Here's how to be what you want to be. Cultural stereotypes. When it comes to interesting boys in STEM careers, they are already primed to be receptive to the messages about manufacturing career pathways. Let's look more specifically at career stereotypes. Consider these first careers: cosmetologist, nurse, elementary education. These are stereotypical jobs for females. And what about construction, geek squad, computer science, manufacturing, and engineering? These are stereotypical for males. Non-traditional career programs are defined as programs that prepare students for occupations that employ less than 25% of either gender. One thing to note is that jobs that are non-traditional for females, like the last ones that I showed, tend to be jobs that are high wage, high skill, and in demand. Author Chimamanda Adichie, in her TED Talk, The Danger of a Single Story, says, the single story creates stereotypes, and the problem with stereotypes is not that they are untrue, but that they are incomplete. They make one story become the only story. So if we think about our friend Dilbert. My dad was a Dilbert. Actually, his name was Gilbert. He was an engineer for the space program in the late 60s and 70s. He had the flat top haircut, the glasses, the pocket protector, the short sleeve button up shirt. Like Adichie says, it's not that stereotypes are untrue, it's that they communicate an incomplete story about who can be an engineer. If I had thought that you had to look like my father to be an engineer, I may not have considered it a career. But I had a high school counselor that instilled in me that women could be engineers too. I would strongly encourage you to watch The Danger of a Single Story TED Talk. Let's think about single stories. Again, take some time to consider this prompt, stop the recording, reflect, and write in response to the question. What single stories are female students at your school or institution exposed to that keep them from pursuing programs that lead to manufacturing operations? Think about, where do these stories come from? And how do we battle these single stories? The second Advanced Manufacturing Pathways online course, called NonTraditional Student Success, Perkins Basics and Beyond, explores the reasons for participation or lack of participation in non-traditional careers. As well as examining Perkins' core indicators, this course identifies the root causes and illuminates the supporting strategies that can affect the success of your CTE or pre-manufacturing classroom or program. Some of the topics covered include stereotype threat. Stereotype threat is defined as being at risk of confirming as self-characteristic a negative stereotype about one's group. So how do we coach students to achieve in areas where they are a minority? Also covered is mindset theory. Mindset theory is based on the research of Dr. Carol Dweck of Stanford University. Fixed versus growth mindset is explored. Self-efficacy is the belief one has in their ability to complete a specific task or to achieve a specific goal. It answers the question, can I do this? So as educators, how can we use coaching and feedback strategies to positively affect students' self-efficacy? Attribution theory. Attribution is the rationale we use to attribute causes to things that happen in our lives and how we make sense about our own and others' behavior. So we need to ask ourselves, to what do the girls in our lives attribute their success? Is it luck? Is it just that they're smart? Or is it hard work? Examine this online course and find out more. Lastly, external root causes are also examined, such as the impact of school climate on students' choices. Along with research-based theories, the program improvement process for equity in STEM is introduced, as well as strategies are introduced to address each root cause. Part of what we need to do as educators is to change the message that students get about careers in manufacturing, to challenge some of the old messages or stereotypes, and to attract young people to careers in manufacturing. The National Academy of Engineering commissioned a study to identify and test positive messaging about engineering to improve the public's understanding of the profession. The study found that the branding of engineers must be modified to appeal to different audiences, especially teenage girls. By changing the conversation from an emphasis on math and science to the value that STEM has for society, we can attract more students to STEM disciplines. These changed messages apply to manufacturing as well. When we talk to students about these careers, it's imperative that we use specific messages to guide our conversations to increase student awareness of opportunities in manufacturing and to spark students' interest in STEM, manufacturing, and other non-traditional careers. It's important to describe manufacturing careers to your students using these three messages. Manufacturing professionals make a world of difference and help shape our future. Manufacturing products are essential to our health, happiness, and safety. And lastly, manufacturing professionals are creative and collaborative problem solvers. If you're recruiting into these career pathways, it's important to relate your career messages to the basic work values, thus increasing interest and awareness of your students. As we look at teams that make up a manufacturing operation and the questions they are trying to answer, think about these new messages: that manufacturing professionals make a world of difference and help shape the future, that manufacturing products are essential to our health, happiness, and safety, and that manufacturing professionals are creative and collaborative problem solvers. So looking at the first group here, this is product design team. They are asking the question, what are we going to create that makes life easier, better, or safer for people? The process design team asks, what technology and processes should we use to create the product? The production team asks, how do we use technology efficiently and safely to produce the product? The customer support and sales team asks, how will we sell the product and its value so that people will want to buy it and will be happy that they have it? The distribution and inventory management team asks, how do we secure parts for production, manage inventory, and distribute the final product? And then lastly, the quality assurance team wants to know, how will we know that the product is safe, strong, and reliable? As you can see, manufacturing professionals are creative and collaborative problem solvers. They make a world of difference and help shape the future. And manufacturing products are essential to our health, happiness, and safety. Based on the literature, there's a strong correlation between how well your job or career aligns with your work values and your job satisfaction. The 4 key work values from which we make decisions on our career are intrinsic values, which typically refer to the importance placed on autonomy and interest. Manufacturing careers are interesting, and many roles can allow for independence. It's important to note that younger populations are increasingly opting towards careers based on intrinsic values. Social values refer to an importance placed on working with people and making contributions to society. Some of the messages that speak to someone with high social values are: manufacturing professionals are highly collaborative and make significant contributions to society by making new products that solve problems for people. And extrinsic values refers to importance placed on making money and having job security. As mentioned earlier in the session, manufacturing jobs are in demand and pay, on average, a salary that is 12% higher than all other jobs. Prestige values refer to importance placed on having a prestigious and respected occupation. Manufacturing careers lend themselves to leadership opportunities and upward mobility. Many recruiting messages for manufacturing careers focus on extrinsic work values such as pay and ignore other work values that may resonate more loudly with females. Also, it's important to note that every person is likely to have some motivations and values from more than one of the work value quadrants, and that these can change over time. But the important thing is to recognize that there are different ways to talk about careers. The third Advanced Manufacturing Pathways online course, STEM for Every Student, explores the demand, opportunity, and multiple pathways available to your students in STEM careers. Concerted efforts to expose all students to STEM careers using terminology that is interesting and appealing can reverse misconceptions that encourage more students to consider and ultimately choose a STEM career. In this module, you will learn about the demand for STEM professionals in the workforce and examine statistics that demonstrate the gender and racial disparities within STEM fields. You will understand that our world is engineered and learn about the grand challenges for STEM in the 21st century. You will practice using the Bureau of Labor Statistics Occupational Outlook Handbook to help students explore opportunities and pathways to STEM careers. You will distinguish the 3 positive and effective messages about STEM and relate the 4 key work values, intrinsic, extrinsic, social, and prestige values to STEM careers. NAEP's team has scoured the research on attracting females to non-traditional careers and distilled that information into 9 key strategies. You can access information on the Make the Future Learning Management System about each of these strategies, including samples and suggestions of what to do and what not to do, and resources that you can use with students and their families. These equitable recruiting strategies are broken up into 3 subgroups: Inspire, Explore, and Expand. The first 3 strategies are intended to help you inspire girls as to the possibilities that exist in a future career in advanced manufacturing. These strategies will help you to inspire them to attend recruiting events and to learn more. Inspire strategy number 1, reach out to middle and elementary school students. It's never too early to get students thinking about their careers. Students' decisions to pursue STEM careers, such as advanced manufacturing, are directly influenced by experiences at the elementary and middle school levels. Yet often efforts to engage students are directed at the high school level. Many such activities are designed to recruit students to enroll in advanced course offerings, to engage in summer experiences, and to take part in informal learning environments, after-school clubs, or other experiences meant to get them interested in advanced manufacturing careers. But these efforts, unfortunately, may be too little, too late. Inspire strategy number 2, use invitations and make it personal. Societal stereotypes about who participates in certain career fields send strong messages to girls that they don't belong and are not welcome. This can stop them from taking the risk to explore non-traditional careers, such as advanced manufacturing, and can impact their self-efficacy regarding their ability to succeed in STEM careers. Even if girls are welcome to your programs and events, their perceptions of the societal stereotypes may stop them from volunteering, signing up, or taking other actions to participate. Sending a personal invitation to a female student to participate in an invitation-only activity can be the incentive she needs to overcome her doubts and ignite the spark to want to learn more about careers in advanced manufacturing. Inspire strategy number 3, create exploration experiences for targeted students. Recruiting opportunities that target particular groups of students can combat stereotypes and offer girls and other underrepresented groups in STEM a chance to consider and explore careers in advanced manufacturing. These environments also contribute to a sense of collaboration and community and provide an opportunity to explore a pathway in a low-risk environment where their performance is not evaluated. Advanced manufacturing needs employees with advanced manufacturing skills, competencies that girls can attain and provide. Girls tend to gravitate towards careers that allow them to be creative, to work in a caring field that provides positive benefits to society, and to collaborate in teams. Creativity, caring, and collaboration are the 3 C's that have been connected to motivation and engagement for many students, especially women and students of color. Try focusing your activities and events on the 3 C's to demonstrate how advanced manufacturing professionals can make a world of difference and help shape the economic future of the United States. Once you have their attention, the next step is to keep it. A big part of your job in teaching potential students, helping them to explore the opportunities in advanced manufacturing. We offer 3 strategies to help you design your recruitment events and use equitable instructional strategies. Explore strategy number 4. Use same gender, same race, or ethnicity role models. One of the key ways to build self-efficacy is providing vicarious experience. Vicarious experience refers to learning through observing others perform tasks, and it is a key way we develop our own sense of self-efficacy related to a task. For example, while observing a more advanced student, a novice thinks, hey, if she can design and construct a working robot, so can I. Role models can provide vicarious experiences for girls, and they are especially influential when they are perceived as similar to the observer. Indeed, research suggests that vicarious experience is a particularly powerful determinant of girls' and young women's STEM self-efficacy. Role models can help students see themselves in a pathway or career. Using role models that represent the diversity of your classroom or recruiting pool can enhance the power of this vicarious experience. We will explore more about role models here shortly. Explore strategy number 5. Provide repeated exposure to advanced manufacturing careers. One and done is not enough. Student perceptions of careers change over time, and their knowledge of the wide array of job opportunities in advanced manufacturing is limited. Even if students have family members or other people they know in advanced manufacturing, they may have limited understanding of the variety of skills, pathways, and jobs in the field as a whole. Repeated exposure and providing a wide variety of experiences related to advanced manufacturing can help students experience and understand the wealth of options available to them. Explore strategy number 6. Use real-world, interactive, hands-on activities. Interactive hands-on activities are ones where students experience an activity that models or mimics certain careers. Giving girls a chance to try and ideally master a hands-on activity related to a non-traditional career can give her the self-efficacy to pursue that career. Self-efficacy measures a person's perception of his or her ability to achieve a certain goal and is greatly increased by exposure to a task and mastery of that task. Once we try something and succeed, we gain confidence that we can do it again. Self-efficacy and one's career pathway choice are positive correlated, so developing a girl's sense of self-efficacy around STEM can impact her career choices. Providing hands-on activities can fuel self-efficacy related to STEM tasks and competencies that can get her energized about pursuing a career pathway towards advanced manufacturing. Being hands-on is especially important because it allows students to engage in kinesthetic learning. Studies show that students learn best when learning is active, when they are engaged in hands-on activities, and when they are involved in what they are learning. I would like to explore the use of role models a little bit more. Role models, as previously mentioned, can have a big impact on students' beliefs about what they can accomplish. When role models are similar to students, the students find it easier to envision themselves completing the task or working in the field successfully. Certain characteristics make role models more effective, such as perceived similarity with a learner, as well as credibility, enthusiasm, and competence through effort rather than innate ability. It's important to include diverse models that represent the diversity of your classroom. NAEP has created a 30-minute training for role models based on these principles. Invite your role models and mentors to watch this YouTube video. The important thing is that role models and mentors should promote proper and positive STEM messaging, dispel stereotypes and challenge misconceptions, appeal to student work values, as previously mentioned. It's important to focus on hard work, not talent or luck. Look for our resource module for specific resources for role models in your classroom. The last of our 3 equitable recruiting practices, enriching or expanding the recruiting experience by engaging parents, businesses, and community organizations, can amplify the impact of your events and messages. We offer 3 strategies aimed to help you develop the key partnerships with influential people in students' lives. Expand strategy number 7, communicate with parents and caregivers. Caregivers have a huge impact on their children's career decisions, especially for African American and Hispanic girls. Using culturally responsive engagement strategies can greatly influence participation. Engaging parents and providing them with the experiences and information they need to inform and successfully support their daughters is critical to your recruiting effort. Minority parents are typically less likely to be involved in school-based activities for many factors that have nothing to do with their interests. By providing various and regular opportunities for parents to volunteer or participate in your activities, and by considering support resources such as childcare or transportation needs, you can increase parent attendance and engagement. Remember that parent engagement doesn't always have to be at events or face-to-face. Expand strategy number 8. Partner with community-based organizations. Develop a strong workforce pipeline for STEM careers, and advanced manufacturing provides benefits to the entire community. Community-based organizations, or CBOs, can be a critical link to help you inform and connect with students and their families. They can make connections between the experiences students have while attending community programs and the work they are doing with them in school. They can also help you learn a bit more about the families you want to reach and the best way to work with them. CBOs expand student experiences through after-school and summer programming, as well as supporting in-school activities that align with their missions. Many students perceive CBOs as safe options that can provide culturally relevant activities. Our last strategy, expand strategy number 9, connects students to meaningful work-based learning opportunities. While community-based organizations can help you link to families and students, you want to reach business and industry partners that can be valuable as well. They can help you build strong programming by providing speakers or role models, equipment for hands-on activities, real-world problems to frame your lesson plans, opportunities for field trips and tours, student scholarships, job shadowing, internships, apprenticeships, and professionals to serve as coaches, judges, or tour guides. Businesses are interested in diversifying their workforce, so your efforts at recruiting girls and underrepresented populations will be strategically important to them. They will want to work with you to build a diverse workforce pipeline that will benefit them in years to come. In addition to equitable recruiting strategies, we would also like to briefly explore some equitable instructional strategies that can be used in your classroom, particularly when utilizing recruiting strategy number 6, real-world interactive hands-on activities. Educators can help students consider a wider range of career paths, including manufacturing, by using these equitable instructional strategies. These strategies have been identified to increase motivation, engagement, and success for all students. The first strategy, intentionally select teams. Teams with only one student from a marginalized ethnic, racial, or gender group can be isolating and create a negative experience for the student. Beyond considering social, academic, and behavioral aspects when creating student teams, try to keep at least 2 students from any one group together if possible. Rotate roles. Student roles within a team can be dictated by gender or racial stereotypes, such as boys taking leadership roles and girls taking secretarial roles. Allow your students to choose their roles initially, which provides them with some level of comfort. However, requiring students to rotate roles is also important so that they learn new skills. Role rotation can keep students from feeling limited by gender or racial norms. Real-world connections. Skills and content that are connected to real-world outcomes can motivate students to engage in learning. So whenever possible, make learning matter by tying it directly to their community. The power of storytelling. When using a storytelling approach, while it may take a little time, it is a powerful way to engage students, females, and especially those from Native American, African, Latino, and Asian cultures. At the Center for STEM Education at the University of Colorado, Colorado Springs, students that engage with scenario-based or storyline STEM activities and camps were found to choose a STEM major 3 times the national average. Student-centered learning and student agency. Whenever possible, have students self-select topics. Have them do the work to uncover ideas and apply knowledge themselves, rather than receiving information from a teacher. This process of active learning increases academic achievement, motivation, higher order thinking, and skill development, and is particularly powerful to engage historically underrepresented people in STEM, such as women and girls. Using role models. As previously mentioned in the recruiting strategies, role models can have a big impact on students' beliefs about what they can accomplish. As part of this introduction to equity and preparing tomorrow's manufacturing workforce presentation, we introduced you to Make the Future Connecting Girls to Manufacturing project. I gave you an introduction to NATE, who we are and what we do. I included information about the Toyota Foundation's goal to increase participation of females in advanced manufacturing programs, and information about the Advanced Manufacturing Technician, or AMT, program. I shared information about NAEP's research, educational equity framework, particularly NAEP's culture wheel. We looked at how NAEP's equity work can be applied to increasing participation of females in advanced manufacturing. We have created a suite of tools that you can access on NAEP's learning management system called the Advanced Manufacturing Pathways online courses. Our suite has 8 modules, the first being this video training. The next three modules on NAEP's online management system, we looked at these other three advanced manufacturing pathways online courses, that being micromessaging to reach and teach every student, non-traditional student success, and STEM for every student. These online courses were designed to cover many different career paths, but our intention is for you to think about what you've learned through the lens of manufacturing. We suggest that as your next step, you complete the micromessaging to reach and teach every student, as that digs deeper into NAEP's culture wheel and provides the foundational framework for the other two courses. The fifth module is a networking space intended to be a virtual discussion location where you can share information, resources, and materials. The sixth module contains more information on our 9 best practices in equitable recruiting strategies that we introduced here. Each month, we will add items that you can download for use with your partners, your students, and their parents. You will also have access to our YouTube channel where we will curate videos that you can use with your students and their families. In addition to the tools, our participants will have the opportunity to work face-to-face at the annual Federation of Advanced Manufacturing Educators, or FAME conference, and the NAEP National Summit for Educational Equity Summit. Recruiters and educators from 7 states will be engaged in this project. We are ready to provide opportunities for you to learn and network with each other. As a result of this Make the Future project, we hope to enrich existing relationships and establish new ways to engage and recruit female students to educational programs aimed to build tomorrow's advanced manufacturing workforce. Thank you for your time and attention today.